Hello, welcome to the channel. My name is Victor, and I'm going to be your anchor for this training. So this is the Data Analytics Essentials series on the channel. If you're new to the channel, don't forget to subscribe. You could have, if you have questions, you could ask on the comment section, or if you're taking this training as part of our remote or part of our physical classes, do well to ask your questions in the training group and mentorship group, and any of the trainers are going to give you answers. Okay, so this is the series where we're considering Excel, SQL, and Tableau. Now, we've looked at the processes. We've looked at very, very important aspects of what it means to be a data analyst, what our roles, what our functions are. Here, we are going further to start looking at some of the other sections of the process, which is preparing and cleaning our data for analysis. Now, most of the time, your data is not going to come clean. Your data is not going to come in the right format. Take a very simple example is where you have some persons give you data in centimeter for height, for instance, and some give you in inches, some give you in feet. You want to standardize, normalize, and clean these data sets to become to fall into standard so that you can have one metric, one unit. There are times also when you have data that is if you see one is rounded up to 2 decimal places, the other one is to a whole number, the other one is to 3 decimal places. This is the time you have to do some cleaning, sorting. This is the time you have to now decide, okay, am I going to use 2 decimal places? Am I going to use 1 decimal places? Am I going to round it up to the nearest whole number? So that's what you're going to be doing. And also here, you're also going to be looking at deciding whether you're going to depending on whether it's a streaming data, whether it is static data, whether you're going to be analyzing right at the same time, or whether you're going to be storing before analysis, or whether you're going to be whichever situations, depending on what the business needs are. So in this module, we're going to be looking at sources of data, how data comes in, and there are different types and formats. Then we're going to look at structured and unstructured data. Then we'll look at data preparation, the extract, transform, and load, or the extract, load, and transform. Here, there's a reverse. And especially when you are dealing with big data, especially when you're using, let's say, Azure, or you're using Amazon or the BigQuery for Google, you might, when you have terabytes of data, that will not tell which of them you should use and the rest. We'll look at the differentiations. Then, of course, preparing and cleaning data for analysis. In this module, we'll start the process of preparing data for analysis. During this step of data analysis process, you will make sure that your data is relevant to the purpose. I said it earlier on that one of the reasons why some research work, some analysis are not successful is because they miss out on the objectives of the research. They miss out on why they need to carry out those research. If you are following an agile methodology, this is the time to go back and look at your objectives and see how to get the right data. Because if you get past this stage and you don't get the right data, what it means that you will. I've seen situations whereby researchers are trying to, at the point of analysis, that's when they now understand that they've not gotten sufficient data. At the point of analysis, that's when they're now realizing that they didn't get the right parameters. Let me give you a classical example. Okay, we had some persons sign up for some programs, and the goal is to send maybe an SMS to everybody. But guess what? We had hundreds of persons fill that particular form showing interest to run that particular free program sometime last 2 years. As at the time we wanted to send an SMS notifying all of these persons that, okay, the event is on so date, lo and behold, we didn't collect phone numbers. And what that means is that because there's a lag in time between when you're going to send an email and when people are going to give you a response to plan the event. So we typically didn't hold that event while the right data was not collected. Yes, the objectives were defined, but the right data was not collected. So there was nothing to clean, there was nothing to sort, there was nothing to even analyze, and you cannot make use of that data set. So it's always crucial for you to always prepare. And when you get to this stage, then you want to make sure that you have things meet their purpose, you want to have the correct format, and you want to remove corrupted. And we're going to look at how you're going to deal with missing data. Take, for instance, you have age, or you have KPIs or some performance, and you have some data that is missing. How do you treat that? How do you address that? So these are some of the objectives we're going to be looking at in this module. Sources of data. Selecting relevant data for analysis includes determining the types of data, like I said, that you need, and finding a source for the data. If you've defined your objective, this is the time to ask, okay, where am I going to get the data? When selecting data for a project, it's important to focus on finding data that might provide insight into your original business question. There must be a connection. For example, if you are seeking to understand demographic characteristics of people who bought product X in a past year, you should only be using data that is directly related to product X. If you go get data for product Y, then you will not be able to make an inference. You'll not be able to make a decision on that particular product. This process is crucial to ensure the validity and reliability of your analysis. Sometimes the data you need to answer your question isn't readily available. It may be necessary to establish new procedures to collect the data required for analysis. Take, for instance, we've done the research for HIV patients for pregnant women across a particular city for an organization. Now, at times, the data that you need to be able to conduct that research is not readily available. So you have to do some writings. You have to seek make sure that you meet ethical guidelines. Then you submit to the relevant authority. Then you are given permission to go collect that data, or to administer the data, or to now serve those to serve questionnaires to now generate the data. And that brings me to what we call primary and secondary data. So primary data is data that you get by yourself, by your research team, whereas secondary data is that data that is gotten by somebody else and you want to use to do your own analysis. If I go to Kaggle now and download a particular data set, or I go to GitHub and download a particular data set, that's a secondary data set. But if I do some questionnaire, or from my own website, I export my own data, you call that what? Primary data. Okay. Let's see if we can see some more differences. Primary and secondary data. Okay, let's see images. Try to see some. Awesome. Meaning, so primary data collected by researcher himself, like I said. Secondary data collected by other persons. Originality, original or unique information, because you have full 100% control. Not original or unique information. At times, it might be falsified. You wouldn't know. So you're going to rely on somebody else's work. If you finish your own work and you upload it to a research repository, you upload it to any repository for storage of data sets and the rest, and somebody else uses it, it becomes secondary for that person. Adjustment doesn't need adjustment. It's focused because you decided the variables. If you say you want to check obesity, that means you're going to get people's age range, you're going to get their height, you're going to get their weight, you're going to get their geographical location, you're going to get their maybe what educational qualification they have, in what sector they work, how many times they eat a day. So its focus is direct. So most secondary data needs adjustment to suit actual aim, because that particular research might be having a slightly different objective than yours. And of course, some of the sources can be you doing your own survey, doing some observation. Have you seen people, maybe road traffic warders, road traffic officials, or policemen? You see them get to a particular place and they do some observations. That is primary data. or you see them count vehicles or count vehicular movements. So that is observation. It can be experiments also. Then for secondary data, most of the times you're going to be going to internal records, you're going to be going to hospitals, you're going to be going to government establishment, you're going to be going to, you're going to get to, for instance, in Nigeria, we'll talk about Bureau of Statistics. In the US, you talk about data.gov, US data.gov. So this should be Singapore. US. Okay, data.gov. In the US, you call it data.org, data.gov. So you have quite a lot of data sets on the site, quite a lot. Highly, very detailed data sets on different kind of things. Okay, let's say I'm looking for COVID data sets. I'm going to say all manner of data sets. And this is going to be classified as secondary data sets. Secondary data set. Okay. I think so. You have all of that. So need for investigators, needs team of trained investigators. You don't need to get people to go collect the data, all of that. This is very costly for you to carry out your own research. This is economical because it's already done. And you have quite a lot of differences, very detailed, about 16 of them. Right? So I think I love this. I'm going to see how to get this into my slide. Oh, shit. Okay, let me see how to get this image into my slide. I love it. Resume from where I am. I'm going to end this slide. I'm going to duplicate this slide. New from slide. Change this one. Yes. Types of data sources. Okay, I think we're good to go. So though not clear, but I think manageable. So you have types of data sources. What will be my source now? My source is going to be Killian City Life, right? So if I need to reference, I will say I'll reduce this a bit and insert a text box somewhere here. I will now say add the text. I think I should just paste very big, reduce it very well. So call this source. Expand this a little bit. Okay, so you have types of data sets. So you have it very, very well. So for most of our students taking our classes, you're going to have access to this document. So very, very key. So the idea here is that when you're trying to get data set, make sure that you're getting data sets that meets the needs of what you're trying to do. So some questions that you should ask yourself when selecting data sources are: what data points are necessary to inform your analysis? Do you already have access to this data, or must I find the data from other sources? How reliable, verifiable is the data set? How often is the relevant data collected and updated? Because you don't want to have stale data, except you are getting data for a particular range, for a particular, let's say from 2005 to 2010, that kind of thing. So, but if you want recent data that is always updated, then you have to be sure of that. Then, of course, data in the format that you can use. You see some data sets, they don't come in Excel sheet, they don't come in CSV files, they come in hard copy paper. It then means you're going to be doing some conversion. So you might want to be doing PDF to Excel converter online, or you can get a software that you're going to purchase, because if records are in PDF and in document format and those things contain table, tell me how you're going to convert them and now have some form of tables. So it's going to be typically hard for you. So you want to understand what you are getting. So it's not the point where it's not time for you to pick the what was it called? Pick the data set. Then you're now like saying, I thought it's already Excel sheet. I wouldn't have to convert from PDF to Excel, all of that. So be very sure of what you're trying to do. Okay, so let's look at static and streaming data. So if you are in an airport, you see you have a dashboard that shows streaming data. That was an example of streaming data, because the data is going to be updated real time, right? You have weather reports. Some of those are streaming. They're not static. They're not at rest. Two types of data that analysts work with: static and streaming. Data is received and stored prior to performing the analysis. So if I need to collect the data, export it before I start analyzing, you call it what? Static data. If I need to analyze right while whatever is happening, take for instance, for a sales dashboard for a very large enterprise, they're going to have a monitoring board where they can see everything live. It's going to be pulling up that data from the database and doing some visuals for them. So let's look at different data types. Now, you're going to see that when you are using your tools, your softwares, your applications, you're going to be seeing things like string, integer, numbers, floating, data and time, boolean. So what are all these? For all the different types of data that you have them in types. Textual data are called strings, right? Letters. Integers, numbers, right? But they don't include decimals. So it is floating points that we call decimals, 25.556. So you call that floating. Then date and time, then of course Boolean. And there are certain times your analysis you want to do a minus from a date. Somebody was given birth to in 1950 and he's alive today. So you want to at times you get a data set, and what you have there is age. Sorry, what you have there is not age but date of birth. So because their age keeps changing, if I come around to do the analysis, the age I'm going to get this year is going to be different from the year somebody else is going to do at another time. Right? So at times you might do some computation, you might do some comparative analysis, you might do some deduction. So the data in the right format is very important. So if I have a particular age, I could do today's date minus that particular date. We're going to be doing that in Excel and Tableau. Then of course, Boolean is true or false. And there's one assignment I want to give you guys. True and true, true and false, false and false, true and true. I normally give my students, we call this logic. So it helps you to be able to understand some algorithm, true and true. So the truth table. So we call this logic, De Morgan's law. So it helps us to be able to understand logic to some extent. Or should I just do this in a separate video altogether? For most students that are going to do Python, we use this when we're trying to call data from a particular table, and we want to return only true values to be able to maybe have a table. So when we say true, true, and true, true, and true, we're trying to say, okay, this condition must be satisfied and this condition must be satisfied. I'm a man. I am taking data science training right now. So true and true. Is it true? Yes, it's true. taking data science students now. This is roughly around 2 a.m. In the wee hours of the night. Now, am I sleeping? False. So in and, when you're doing and, you're trying to say that both conditions must be met. But in or, any of the conditions must be met, right? So it's a nice way to in programming, most of the times you want to use that to be able to make decisions. Take, for instance, if you say you must have an account with the bank and you must have minimum of ₦1 million or $1 million before we give you a loan. If the condition is an and, it then means two conditions must be met. So if you come to the bank and you don't have up to ₦1 million or $1 million in your account, and you have stayed in the bank for 100 years, you're still not going to get a loan. But if the condition, so the system is going to return the parameter and say, no, you can't give you a loan. Contact your account officer or something. In the or, we're saying that any of the conditions must be met. So that's why you see in the or table, you see that you have most of them true, except for false and false. Okay, so let's get back to different data types. So that's where we use Boolean. So Boolean is true or false. Then you have other standards. So you have the ISO International Standard Organization. You have the request for comment. So these are standards for numbers, standards for representing some dates, some time, and depending on the data set that you got, you should just be very sure of the standard that is being used, so that if you're doing conversions or if you're doing minus a particular date from a particular date, you use the very right standard. Okay, so let's look at structured and unstructured data. Now, structured data refers to data that is entered and maintained in a defined field within a file or record. So you can easily classify, query, analyze structured data. So the characteristics are they are very organized, they're defined. You have them in tables, they have vertical columns and rows. The content is formatted, most of the times it's sorted. And this is the kind of data that analysts will always love, because you just need to load it into your software and you start plotting, you start creating graphs and the rest. But there are times where CSV is also a type of structured data. But there are times where you're going to have data that is not structured. Relational databases are structured data set, logs of a website, logs of a machine, logs of your PC. If I say log right now, it will be possible for me to get the log of my system in my event viewer, right? Spreadsheet is also structured, sensor reading from maybe a thermometer or let's say either a thermometer, what other sensor do we have, or pressure, or it can be tire pressure, it can be atmospheric pressure, it can be anything, right? Sensors, it can be your heartbeat. These data are structured. Transactional records are also structured. Then let's look at unstructured data. Take, for instance, you have a website. A website is going to have both photos, images, text, numbers, and the rest. If you want to analyze, you will be picking maybe only the table to analyze. When we start doing Tableau or later on Power BI, you're going to see that we can actually crawl a particular website page and pick the tables from it and start analyzing. So, but what you need to understand is that unstructured data is not organized. And as analysts, if we have such kind of data, we need to go through the cleaning and transformation stage in the data science process. So unstructured data, when you scrap web pages, when you have no SQL, because no SQL databases is a type of database, it's going to have different formats, right? In data lakes, especially for big data, you're going to have where a place like where you put in different kind of data sets before you now load it for analysis. APIs at times is going to collect for different interfaces are going to collect data from, take for instance, let me give this simple example. API, for instance, is what we call application programmable interface. So it's just a way for another application to connect to another application. So that's why it's called an interface. It's just like a telephone line. You pick up a telephone line, you call somebody in Europe, or you call somebody in Africa, or you call somebody in Asia. That telephone is like your interface. So it just helps communication between point A and point B. You have a website also. You have your bank. Then you have a payment gateway like PayPal, Paystack, Flutterwave, to checkout, Bitcoin. Those are payment gateways. If you want to be able to collect payment and it gets to your bank, what you do is that you go to any of the payment gateways, you configure them so that they can accept, so that people from your website can pay you. At the end of the day, the money hits your bank account. So the only way you can do that is if the payment gateways provide you an API and you integrate it on your website. So when somebody comes on your website, he pays, it goes to the payment gateway, the gateway collects a commission and it hits your bank account. So many large service providers such as Facebook provide standardized interface to collect data from them automatically using APIs. Now the thing is that, let's say you want to call out information from an API about me, my Facebook account. What you're going to get from my Facebook account is not going to what you're going to get from Mr. B. It's not what they're going to get from Mr. C. This person might have 1,000 posts. I might have just only 3 posts. The other person might have 50,000 posts. So you're going to have some kind of variety on what you're going to be getting. And most of the times it's going to be unstructured. Now, there's what we call ETL, ELT. So it's just how you move data across pipeline, how you move data through your preparation process. I've had somebody tell me that I want to learn ELT. I was like laughing. I told the person that it just depends on how you want to prepare your data. So the first stage is extract, the next stage is transform, the third stage is load. Now, you have 2 flavors of it. So the first one, you extract the data first, you transform it, that is you clean, you merge, you sort, you clean, then you now load it. Whereas this other one, you extract, you load before you start transforming. So let's take a closer look at the 3 processes in the ETL process. So extract, in each step, data is collected and gathered from various sources. So it can be in different formats like relational databases, NoSQL, flat files, XML files, extensible markup language, and other formats. Transform, this is where we start doing some conversion. Like I talked about metrics, you got age, and somebody is mentioning his age in months. Another person is mentioning his or her age in years. Before somebody is mentioning his age in decades, somebody can say, I'm 5 decade 2. Somebody says, I'm 3 decade 2. Another person says, I'm 52. Another person says, I'm 50 months old. So you need to do some transformation. You need to set useful rules to transform the data source, right? So that at the end of the day, when you want to do analysis, you are working with one standard. Now, it might seem to some of us that some of the things I'm saying now don't make a whole lot of sense. So when you start doing analysis, you're not going to see the reason why you need to do this. And these are standard practices. Then, of course, load. Then before the analysis now happens. Okay, so we've learned quite a lot. We've learned about data sources, structured and unstructured data sets, and of course, data preparation. Okay, I'm going to see you in the next series where we're going to start trying to use Excel. We'll start getting to the tools now. We're going to start looking at Excel. We'll start going to look at SQL and, of course, Tableau. If you have a question, don't forget to ask in the comment section. If you are taking this training as part of our premium classes, or our VIP classes, or our physical classes, or our remote classes, whichever way you're taking these classes, Do well to ask your questions, and any of our trainers will respond to you. See you in the next series.